graphing points, which is cool and all, but oh my goodness, that's like, I don't know, what, pre-algebra as compared to calculus. So we need to get going. So graphing points and polar, that's good. We also talked a little bit about calculus and reminded ourselves that, did anybody check your endeavors? Do you have first and second derivatives of polar curves? Okay, so I need to check the endeavors and try to make sure we know what we have, or we have what we know.
Isn't it the same thing as comparison?
Yes, except for those of you guys that were here, can you talk through why this example was a bit unique? It's so easy, right? It's like parametric. It's y prime over x prime, but you don't have x and y. Well, how can you take y prime and x prime if you don't even have x and y? How do you find y prime without y? How do you find x prime without x? You make them. How do you make them? You make them because you need to do r cosine theta and r sine theta. They're going to give you a function. But unlike parametric equations, which are naturally what you need, x of t, y of t, when they give you a polar function, it's not what you need, at least not for tangent lines. So therefore, we had to go ahead and think about the triangle, and the triangle is like, oh, hey, yeah, that's right. We have hypotenuse, opposite, adjacent. And so you need to solve using cosine, you need to solve using sine. And then you have to find the prime. But what's the struggle with the prime? If you were plugging in a function times cosine, a function times sine, guess what rule you're going to have to use a lot. Product rule. Oof. So if product rule needs to be used, well then, Now there are some people that would say, we can just make something to memorize. What? How can you make something to memorize? There are some people that would say, instead of making x and instead of making y to do y prime over x prime, they would say, well, let's just make a formula to memorize. Now, some of you might want to do that, and some of you might not. How do you do that? Can't we always say, to get dy dx, y prime of theta over x prime of theta, if they give you r, well, wouldn't you always be making x the same way? Right? And wouldn't you always be making y the same way? And whoever r is, wouldn't you always be doing product rule? So some people would say, why don't you just memorize a formula for that? But how do you memorize a formula for that? Well, you do the product rule. So you can do something like, second d first, isn't that going to be r prime cosine plus first d second? Isn't that going to be minus r sine theta? And then couldn't you do bottom, second d first, so r prime sine plus first d second? Oh, did I just take the derivatives the wrong way? Yeah. Well, it's not so much I flipped them, because that's how I make x and that's how I make y. I just took x prime over y prime. There we go. So if you can always make x and y, then you can always memorize this. And why is that a difference? Well, I don't know. It depends. 2 years ago, a little group with George and Amanda, and, well, two Amandas. There was Adeb too, and Joyce and Jackie, and Gerardo. They decided they wanted to memorize it, so they did. I was like, okay, cool, if you want to. Last year, they decided they wanted to make it. Okay, cool. You guys have to decide for you. You can decide for the class. You can decide for yourself. Either way. But let's go ahead and try to figure out what the difference is. Ready? There's this way, or there's this way. So at the end of yesterday, we were trying to solve for this guy. We were trying to solve for y prime over x prime because we had to find the equation of the tangent line. We needed dy dx. We need to plug in. My question to you is, what's easier? Is it easier to do the product rule like that, or is it easier to do the first derivative rule like this? It's up to you either way. It's up to you either way, but one way or another, I want you guys to go ahead and solve for it. So I'm going to go ahead and write off to the side really quickly which way. One way is dy dx for polar when given r of theta is equal to r prime. Yeah, I did the wrong way. Thanks, it's y. r prime sine, r prime cosine, minus r sine, right? Plus r cosine. It's up to you. Do you want to use this one, or you just want to go for the product rule the way it is? No, like pick away and go. Pick away and go. Yeah. Like pick away. Pick away, pick away. Get that tangent line for me. And I'll get them too. You guys get the key information down. So either you're making x and you're going to do product rule here, or you're just going to go ahead and go straight to there from the r. Does that make sense, the difference? In my brain, I dislike having you memorize more than you have to, but I also like you being able to go faster on the AP. If you had this memorized, I think you'd go faster than this. But if you're stuck here and you don't have it as memorized as you should, then you'll be incapable of going there. I think it won't. I think your brain won't make the necessary connections. So I don't know. That's why I want you guys to choose what you think is better. Pi over 6. Then you have to get your x and get your y. Which, if you have to get your x and get your y, you have to form those equations anyway. Well, I guess you could do it this way too. I guess you could plug in there, or you could plug in here. I guess that would work. Because pi over 6, I'm assuming, right? Yeah. Can I ask you to raise a hand so I don't have to put on the board? How many of you guys went for the r prime sine plus r cosine? How many of you guys went for the, I'm just doing x and doing y? Oh, it's like half and half. Then I'll do it this way because that's the way that I wouldn't normally do. Why did Riley do the little like oof when I said no calculator? How much plugging and chugging do you guys have?
Wait, so would this be calculated problem?
No, pi over 6. Now, if you did do this formula, couldn't you have plugged into r and plugged into r prime and then just put the numbers in there? Could have shortened it. Because I already plugged into r, because I went ahead and found x and y using this, so I already figured out that r of pi over 6 is 2. So I just plugged in 2 and plugged in 2 to cosine and sine. I could just plug in for this whole piece and for that whole piece. That's just r, so that's going to be 2 and that's going to be 2 without even thinking about it. I could do the same thing for r prime, so you could do r of pi over 6 is r prime of pi over 6. Just thinking about r prime, that'd be 6 sine of 3 theta. No, 6 cosine of 3 theta. That'd be 6 cosine of pi over 2. Oh, it's 0. Oh, that's nice. So that's 0. That's 0. That's 2 times cosine of pi over 6 would be double check my work though, I did it fast. So I went ahead and plugged in pi over 6 to get r of pi over 6 because I could plug that in the r spot. And I think that ends up being sine of 3 times pi over 6 is sine of pi over 2, which is 1. 1 times 2 is 2. So I just replaced that with 2 and that with 2. I replaced that with 2 and that with 2. I was just trying to save my brain. And then r prime, if I'm doing this one, r prime, you can just plug in. So that'd be 6 cosine of 3 theta. Oh, here. Plug in. Pi over 2 is 0, right? Whole thing is 0. That whole thing is 0. This was so much easier than it could have been. That's 2 times cosine of pi over 6, and then negative 2 times sine of pi over 6. And I think my cosine and sine is in the right order, right? And I think I end up simplify. Is it okay? So which one does look better? Well, here's my rationale, because I want to choose a way and then go for it. Like if you guys want an Endeavor card, we'll make it might be valid. Because couldn't you, for this formula, if you were trying to find you could do hint to find dy dx at theta equals, I don't care, a. Couldn't you just technically off to the side, couldn't you then say y prime of a over x prime of a without having to do like the full product rule of both and then plug in a to like, I don't know, 4 different trig functions, 6 different trig functions, 8 different trig functions? Couldn't you just figure out who's r prime of a? And then sine of a? And then r of a? Not that you would necessarily need to memorize this, but it does cut down the work. And that I just saw, because I had already plugged in r of a for x of a and y of a, so I already knew what those numbers were. I didn't have to go plugging into these trig functions all over again. Because otherwise I would have had to plug in there and 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 plug in there. But look, they're repeated, so why not just plug in r prime? Got it. Plug in r. Got it. Plug in r. Got it. There are some ways to shorten your work and not do as much trig plugging in where you might make mistakes, just because there are pairs that match up. Does that make sense? So maybe we'll keep playing on this and try to see what we think is best overall like as a class. But at the end of the day, we will end up with, I think it's y minus 1 equals negative root 3 x minus root 3. Cool. But in the past, even though my brain comprehends this a little bit easier, like whatever, find x, find y, and go, I think it really does take longer because of all the different trig functions instead of seeing the relationship with r. James?
We actually have a verb for
this, right? Okay. But wait, you have r prime written down? Woo. Go team. I made you memorize that early without even having you practice it? That's okay. Cool. Go team. Then never mind. But you still technically do have a choice as to which way you go. Well, go figure. I didn't know I even went that route. Okay. And it includes this one, yeah? Okay. Doesn't have the second derivative at all, though, right? Okay. Then let me go ahead and just do this. I don't want these on 2 different cards as far as the derivatives. If we have other polar stuff, we'll make it its own card. I'm going to say add 2. And so endeavor number 3 is going to be covered up in the next endeavor quiz. Does that make sense? Parametric polar from the beginning of the year, and then additional parametric polar including vectors from the end of the year. That makes sense though, right? Categorically, right? Okay. Guys, pre-cal or cal? Pre-cal. Why am I going to say r is equal to 5? because it's a circle. Or another way of looking at it is if you had your triangle, who is x squared plus y squared? Can you just make it r squared? So r just equals positive 5? Oh, in polar it can be plus or minus. In polar it can be plus or minus. How about this one? It's not going to be on your forever card or your endeavor card with polar. But what did I just say we could do? So who's secant? Think trig sub. Do it yourself. It's just a triangle. So who's secant? Think trig sub. Like, just go to the triangle. Who's secant? Choshikao. Hypotenuse over adjacent. No. 1 over cosine. Hypotenuse over adjacent. So who's hypotenuse? Who's adjacent? So can't I say r is equal to 3 times r over x? So couldn't I say x equals 3? What? Yes. Why? Multiply up the x, divide the r's go away. I didn't even have to do the square root of x plus y squared. I just played with what I had, and there you go. You can get a vertical line in polar form. Never been able to do that before. We can't graph x equals. We can change our window, though, to be x min and x max. Are we okay, pre-cal? Justin?
Why can't you just plug into the x equals positive?
Because it's 3 over cosine. Oh, you're meaning take this equation and plug in r. Is that what you're saying? You could, no, you could do that. Doesn't that work, though? So you could plug in secant. But depending on... Does that make sense? So just be careful. This one was unique in that if you did plug into x equals r cosine. But the problem is if we're getting like an x and y equation, it won't all cancel out. Okay. Calculus or pre-cal? So which way are you going to go? Go again. Ready, set, go. It's up to you. Are you going to choose equals y equals this time, or are you going to choose the formula? It's up to you. Because it's not a tangent line, so I guess you don't technically have to think about it. Back here today. The one that isn't graded, that one? The multiple choice is marked. You can, I told you you can come by and see it. Yeah, you can look at it with the answer key. Part of what I'm doing tomorrow. For chapter 10? That's in my desk on the folder here. For chapter 11? The one that you took last week, this week, once it's graded, you will get back, you will get corrections. I think we're to 1/5 points. I think we're to 1/5, because we had chapter 9 OT, chapter...
Didn't you say 9?
Oh yeah, we're on 1/4.
Okay.
Chapter 9 OT, 1/2, 1/3, 1/4. Then chapter 11, the one you're talking about, will be 1/5. Yes. Sorry, the one you were talking about was 1/4, and then that one would be 1/5. Review day, work day. Sadly, well, you guys will get it tomorrow in class. I was trying to get it to you so I could pass it out to you, but there is like a little bit of a practice test. It's huge in the sense of like tons of pages, but it's hefty in terms of making you review, if that makes sense. There aren't many problems, but it will make you review. Our test will be Tuesday or Wednesday, depending on how good the video is I'm going to have you watching tomorrow and how comprehensive. No, it is going to be me, but I don't remember exactly where we cut off, and exactly Mr. Brache has issues with videos sometimes. So you guys quick heads up, just for, I'm going to write on here on a post-it on the sub login that he needs to log in with. And on the desktop is going to be CalcBC video. All he has to do is double click and have this turned on. Have the aux cord plugged in. Naomi, you know how to do that. And then have the audio on. Is that cool? Try not to distract him, please. Okay? Okay. Coming back. Sorry. Chose the formula. How you guys chose? Oh, is it the same split? Wow, we changed. Okay. All right. Hey, no. Just I'm going to be lazy. R of 3 pi over 2. That's -1, right? So, oh, literally -1. 2 minus 3. You guys agree? And then r prime is just going to end up being 3 cosine of theta, and then plugging in 3 pi over 2 is going to be 0, yeah? Cool. So when we go to do our formula, I'm doing the formula way, just so you guys can see whether or not you like it. dy dx at, now careful, we'd have to put the at if we're doing the plugging in right away. Does that make sense? So r prime is 0. Oh. R prime is 0. So do I even need to worry about who's cosine, who's sine? And then r is -1. And then this one ends up being, is it cosine over sine? Except I can actually plug in, right? Because cosine of 3 pi over 2 will be 0, and sine will be. But there are different ways of getting there. What happened? Let me come see. Now, guys, we could keep going with calculus, right? Let's not keep going with calculus, but hold on. What would you do?
So this is like dy equals 0, dx equals 0.
Y prime equals 0 and x prime equals 0? Yeah, and then just label them separately as far as horizontal and vertical, true? But what we have to watch out for when they're both 0, doesn't get to count for either one, true? Ah. Ready, set, sketch. I'm actually not kidding. Sketch. Without a calculator. Let me see. Okay. Oh. Maybe it's not making a difference. But remember to group it. I think that makes a difference. That's good? Okay. Anybody know why I'm choosing the ones that I'm choosing? Yeah, because they're just going to be 1/2. So root 2 over 2 is root 3 over 2. I mean, bring on the Mrs. Leon and the memorizing of the radicals, right? Or just use the nice ones and hope that it's enough. Now all of a sudden the sign is -1/2, which would be minus a -1, which is 3. Now sine is -1, which will be 4. Sine is -1/2, which is 3. And then sine is back to 2. Why am I showing you this? Oh, sine is 1/2. Cosine is root 3 over 2. I just did all those points because see how they like, oh, hey, it's going to keep repeating. Oh, no, it didn't. See what I mean? Sure. But maybe not every single value in between, unless you can't see it, and then maybe you should memorize root 2 and root 3 as decimal approximations. Well, if you memorize what root 2 is as a decimal approximation, like Mrs. Leon, and root 3, then you could just plug in over 2. Or you could memorize root 2 over 2 and root 3 over 2 as decimal approximations and plug in. Because they'll be the nasty ones that you'll get, and you won't know how to do them. Is the AP going to ask you to graph and give you points for graphing? No. But is it going to be helpful sometimes to know what the graph is? Because they're not going to show it to you. Yes. So where are we at? We're at 0. Why am I going out 4? What's the biggest I go? Because what's the biggest that sine can be? That's not the question. The biggest r can be is when sine is -1, because minus and -2 will make it +2. Does that make sense? Sine goes between 1 and -1, the range of values between 2 and 4. So I have two. The only angles I'm putting in are my pi over 6s, because those are the only ones I really even found. Remember, we're rotating. For my ones that were gone yesterday, we're rotating. We're not going up 1 over 1. We're going out 1. Out 1 like a circular. Then I'm down to 0. Sorry. Then I'm going out 1 again. Then I'm going out 2 again. Then I'm going out 3. 1, 2, 3. Then I'm going out 4. Then I'm going out 3. Then I'm going back 2. Downwards facing limaçon without an inner. Now, my ones that were gone yesterday, we haven't reviewed points unless you look at the video. But remember, when I get a 3 for 7 pi over 6, what does that mean? 7 pi over 6, I go over 3. No. I go down 3. No. Well, kind of. I connect it with a circular pattern, and I see where's my intersection. Because I is 2 radii, 3 radii. Remember with polar graphing? Okay. Why doesn't it have an inner loop? Because it never went negative. It never doubled in on itself. Why did I cross out all the rest? Because I wanted to have a nice pretty picture, and so forget it. How would you do all of these? You would make a table, and you would think about things like, okay, at which angles will it be nice? And I would go, for sines, I would go the over 6s. Or if it's a 2 pi, or a 2 theta, you have to be careful. Maybe you could go something like a pi over 12, which would be a pi over 6 when you multiply by 2. What am I preparing you for? This guy. What table would you make for that guy? Cosine's nice at pi over 3s, pi over 2s. Yeah, because pi over 4 times 2 would be a pi over 2, or pi over 6 times 2. Does that make sense? So I want it to be a pi over 3 or a pi over 2, but that doesn't always mean that's what I'm plugging in. Does that make sense, guys? And technically, I guess we should throw in our theta and we should throw in our r. Because then I would go ahead and do 0. Yeah, that's fine. But then I do pi over 6, and I do pi over 4, because I'm getting my pi over 3s and my pi over 2s. Is that cool? Okay. That's just reminding us of polar sketching. But once again, I do have a huge old page that says, hey, limaçons, whenever you have a number, another number with a sine or a cosine, guess what happens? Okay. Well, the a over b, and the one that we just did, the a over b that we just did, wasn't it 2 over 2? Limaçons. 2 over 2 is 1. Oh, it's going to be a cardioid, which is exactly what we had. It was a cusp without an inner loop. So you could memorize this whole thing, or you could just make tables and not have to memorize it all. But it might be nice to know that if we have like a plus or minus, it's going to be some sort of limaçon, maybe with an inner loop, maybe with a cusp, maybe with like a little dimple, maybe with just a flat spot. It might be nice to know that if we have some sort of a cosine n theta or a sine n theta, we're going to have some sort of rows with petals. It might be nice to know that if we have just a cosine Or a sign without ends, it's just going to be circles. Or lemniscates, you're going to have r squareds. It might be nice, but do I necessarily want you to memorize the whole page? Not exactly. But I think it would be helpful, though, to know, especially for roses. If n is odd, you have that many symbols, and if n is even, you have twice as many. That's a pretty good trick. And also, it might be nice to think about something like, if it's only dependent on a sign function, what kind of symmetry does sign have? Think power series if worse comes to worse. Odd. Odd symmetry. Well, maybe another way of thinking about that. Odd symmetry means that what's on one side of the axis will not be on the other side of the axis. Sign in the first and the fourth quadrants are going to be different because when you go from here to here, it doesn't match. It's not symmetric across the y-axis. And maybe another way of thinking about it is whether you go a positive angle or a negative angle, cosine is the same. He's going to actually have polar axis symmetry. Whereas sine is going to have the other one. He's going to have pi over 2 symmetry. Do you guys see the sine copying on either side of the pi over 2, 3 pi over 2 line? If it was a cosine, guess where this would be? Since cosine is the same, positive or negative, then he's going to have symmetry going this way, whereas sine has symmetry going that way. Like, there are good things to know, good tricks to graphing, but this is where we need to get today. Not to the pre-cal. Sadly, I'm sorry. All of that besides the derivatives was pre-cal. Even the tables and the graphic. All of that was pre-cal, except for the derivatives and the table line. Here's the big new thing to end the year.
Are we going to get, like how we had last year before exam, we had like those packets of like review for each chapter?
Yes and no. You're not going to get, I mean, there were the 12 from last year that you might still have somewhere that might be good to look over, but I'm not going to give you packets for AB material. I do have packets for the BC material, like polar areas, Taylor-Maclaurin's, which should have Lagrange in there too, an integration, a harder integration packet. What am I missing? Sequences and series, sorry. I think I have like 4 BC specific. Oh, Euler's method's in there somewhere too. Logistic growth is in there somewhere too. But then I just have mixed reviews of everything. Does that make sense?
Are we going to have the extra practice test with you for extra?
More than one, but yeah. But not all of this is going to get fit in before April 13th.
Oh yeah, but just like before.
Yeah.
So after our test next week, we're going to start review?
With AB, even this year, if you guys are thinking tutoring hours, because tutoring them for the AP exam is tutoring yourself for the AP exam, right? They're going to start getting their topical packets. Oh, we could tutor them through limits, and we could learn limits. See what I mean? That's going to start after the mock AP, after spring break. Before the mock AP, they have like a 27 essential topics of calculus. Basically like going through each of the topics, but like a few questions, just to make them review. That's what's going on this week over the weekend, due next Friday. But then we're also going to be doing, I'm getting them AP practice because they haven't really seen it yet. And I think for Saturday, the best thing I can give them is just mixed up practice beyond that one little packet. No, next Saturday. April 6th is next, and then.
How much longer?
Yeah.
How much longer after you take the AP exam do you have left to school?
When we take the AP, oh, you mean like the AP, not the mock AP. APs finish, and we have 1 week and then finals. But our AP is the beginning, so like our AP literally, I think we have like a week and a half.
Okay.
Yeah. Yeah, it's like the Monday or Tuesday, second week of APs. You guys know how last year was.
I can't tell what some teachers.
Mr. Weitzel did too. Every English teacher in 12th grade has given a final as far as since I've been here. I don't know. I'm not the English teacher. I don't totally disagree with them. Oh my goodness. Hey guys. I love you all, but this is hard. Here we go. Guess what? There is a geometry formula. It has nothing to do with calculus about area of a sector. And all you need, it's a circular sector. All you need is your radius, and all you need is a theta. And you can plug it into this formula pre-cal. It's green, right? What's going on with area of polar curves? If these are circular, hold on, guys. What we just graphed, was it circular? Is it a set radius every time? No. So could we just use geometry? No. But can we ever? No. We just use the idea of it. So here's what's going on. It's not a set radius. But if I can make them infinitesimally thin, it would be for a set radius, right? Well, for that little, like, two-dimensional, yep. So what are we doing? Same way that secant lines approach tangent lines, the same way that rectangles approach curves, the same way that disks and washers and shells approach volumes, sectors are going to approach polar areas. But is that hard? No, because check it. The area formula gets plopped into the integral like cross-sectional areas get plopped into volumes, like bases and heights get plopped into areas. Just what's different? In this one, my theta becomes my thickness, my d theta. The same way my base, my delta x became my dx, the same way my depth in volumes, my height became my dx or my dy, my theta becomes my d theta. The integrals are going to make the little slivers infinitesimally thin to take away the error and see what it approaches. So what's going on? If it's d theta, what are my bounds? Function going to be in terms of theta. What am I going to be solving? 1/2 r squared d theta, because that's my area formula. Yeah. Well. Don't worry, let's not stress about that right now. Let's talk about this. Why is the card so small and then the blue stuff after it so big? The card says area of polar curves. For a polar curve, r of theta, the area between the pole is the origin. That came up yesterday. Kathy and I were talking about the area between the pole, the origin, and r equals f of theta for between alpha and beta, between two angles, is equal to 1/2 alpha to beta r squared d theta. R squared, r will get plugged in for f of theta because r is equal to f of theta with angular bounds, except underneath the card says to find bounds for areas. To find bounds, they're going to give them to us, aren't they? Sometimes. So what am I talking about? I'm talking about natural bounds. Come on, area between, we would have to find intersections, right? Disc washers, sometimes we'd have to find intersections. So we're doing intersections just with polar now. For area bounded by one polar curve. To find the period, we can set the argument equal to 2 pi. Remember how I did that the other day? And I was like, hey, this one finishes in pi over 3. Ooh, this one finishes in 6 pi. Different periods might take different thinkings about bounds. But the nice thing is I can set the argument with the horizontal dilation equal to 2 pi to say, what's happened? If possible, you can use your grapher to graph in function mode. Function mode, what? If I can graph two polar curves in function mode, can't I see where their x's and their y's are the same? But wait a minute. I'd have to make x equations and make y equations. Maybe if I graph in function mode, I can find the intersections between r's. We can use symmetry. We can use the pole. When r equals 0, the zeros can help sometimes. You might be like, okay, I'm not hearing that many weird things. Zeros, intersections. With the calculator, go to function mode because we know that polar doesn't work because parametric doesn't work. Neither of them have zeros or intersections. Oh, no, sometimes you can. The dilemma is, how many points are possible for a polar point? Does that make sense? How many ways are there of landing in one polar location? Why? Remember how there are coterminal angles? So one way of landing on a point is just to go straight to that point. What do I mean by straight by? A positive angle with a positive radius. Plus all the coterminals, which is infinitely many, because I could add 2 pi, I could add 360, I could, etc., right? But isn't there another way of going the opposite angle and going a negative r? So is it possible that two curves, technically, their paths intersect in one point, but at very different actual polar coordinates? That's where it starts to get funny. But the nice thing is we haven't even technically talked about area between. We're just talking about one polar curve, one equation. Oh, so it hasn't gotten that bad yet. When it's bad is when we start talking about areas between. This is what you're going to have to look at tomorrow. Areas between versus areas in. What's the difference? Areas of polar curve, you just have one function. You're trying to find maybe just the inner loop, maybe just a leaf of the rose, maybe the entire thing. Maybe the part of the limacon that's outside the loop but inside the limacon. Oh, really? Yeah. The same way they had to stretch you with functions, they had to stretch you with polar curves. Pole, North Pole, South Pole, latitudes, longitudes, navigation. Now the area of polar curves? Ask somebody beyond me. Ask somebody beyond me. Ask the SAT guys, when on earth would you need to find the area between a circle and a... So what's going on? This one's easy. It says find the area of the region in the plane enclosed by the cardioid. R is equal to 2 times 1 plus cosine theta. Where are the bounds? Nice thing is they say cardioid. If it was an inner loop, it makes everything a little bit more interesting. What are my bounds? What's the period? Oh, it hasn't been changed. There's no like multiple argument. There's no horizontal dilation, stretching it or compressing it, making it last longer or last shorter. So what can I do in this one? Easy cheesy. Let's solve. Why did I make an Endeavor card from the power reducing properties for trig? I could pull the 2 out, and those end up canceling. Oh, no, that ends up being a 4, so that's going to be a 2. What happens when you FOIL this guy? I'm golden. I'm golden. I'm really not. I'm really, really not. I'm really, really, really not. Because who is this guy? Now I'm golden. I can integrate. I can integrate. Oh, now I can integrate. I can pull out a 1/2 and I can integrate and I can integrate. With U sub, I can't integrate. So why did I give you the power reducing formulas? It makes the impossible possible. When you have to do it by hand, which sometimes you're allowed to do it by calculator, but do you guys realize you need some practice in doing it by hand if all of a sudden we have these new power reducing things we've never had to do before? So where's homework start? Pre-cal. Where's homework go after that? I don't know, like derivatives and tangent lines and slopes and all that jazz. Where's homework go after that? Areas, and then areas between. What's the one thing we haven't done yet? Area between. Which means you guys can do all of homework except for any of the polar area ones that give you more than one curve. Does that make sense? If they give you more than one curve, you better wait until you watch the tomorrow. Guys, this homework isn't due until when? Monday, but it starts off with pre-cal, and then it goes to maybe slopes and derivatives and those sorts of things. And then if I were you, I'd try to get up to at least a few of the area ones with only one curve tonight. Sound good? Doesn't sound good, but sounds necessary to me. Bye, guys. Well, technically, you could just have a very polar weekend. Anyway, but you can watch